Hello guys, welcome to iTest Learning. Today we are going to look at the problem number 406, Q reconstruction by height. So let's look at the problem description. Suppose you have a random list of people standing in a queue. Random people are standing in a queue. Each person is described by a pair of integers. So pair of each person is described by a pair of integer h comma k. So where h is the height of the person and k is the number of people in front of that person who have the height is greater than or equals to h, which means see 7 is the height of a person, and how many persons are standing in front of this guy. 0 means no one is standing in front of him. So if you look at 4, his height is 4 and 4 people are standing in front of him. If you look at here 1 2 3 4, so like that. So this describes that how many people are standing in front of how many people who who is greater than or equals to that guy. So if you look at here, 4 people are standing in front of him, all of them are greater than or equals to this guy. So 6 5 7 4 5, they're all greater than this guy's height. So you can, the idea behind of this problem is, let's so first let's take the greater values. This guy, this guy and this guy, right? So these are the ones, and next time in the second one you have to take the next greater height, which is this one. So where this guy will come, this ideally one guy should stand in front of this guy. One, only one guy, sorry, this guy, one guy should stand in front of this guy whose height is greater than or equals to 6. So which is, this will go here, right? Correct. Now the next height is 5. There are two. Let's sort out based on the k. Then the 5 comma 0, so it should be 0th position. So it is lesser than 7 and also it is at 0th position. This will come here. And the next value 5 comma 2, uh, two people should stand in front of this guy. That means this guy will come here. If you look at here 7 and 5, there are two guys standing in front of this 5, and the k is equals to 2, which is satisfying the condition. And now the only value we have 4. This should come 1 2 3 4. 4 people should stand in front of this guy, and let's check the condition. All of them are greater than or equals to 4 or not. Yeah, 6 5 7 5, yes, they're all greater than or equals to 4. So what you have to do, you have to sort based on the height, and if the heights are equal, again sort ascending order based on the k, and place them at the right position based on this position number. Then uh, this will be in the right position. Okay, so let's dive into the coding side. So as we discussed, we have to sort these guys first based on the height, and if the height is same, and then again sort based on the k in the ascending order. So let's sort arrays people. We will have to use sorting comparator here, a comma b, because we are sorting a different sort, like ascending and descending order based on height and based on the k, right? So that's the reason. So now if a of 0, so first let's say a of 1 is equals to b of 1, which means the k value, then a of 1 minus b of 1, right? Else just sort it, b of 0 minus a of 0, right? So let's take one list of int, because we have to place these guys at the right position, right? That's why we need to have a list, new array, list, integer, right? So what we have to do now, we have to iterate, traverse through this int p people, and then just what you have to do, list dot add the position. P of 1 is the position, right? And the value of the p, the tuple, right? That's it. Actually we don't need this, can simply do it in the single line. Okay, so now just return the list, convert that list to array, actually this is not how you collections dot to array of int people dot length, and another one is just the 2. Let's try running it. GTH. Perfect. Let's submit this. Accepted. So yeah, thanks guys. And the time complexity for this problem is, for sorting it is n log n, and for traversing it is order of n. But if you look at here, we are traversing just a single dimension. It's actually a 2-dimension array, but we are traversing a single dimension here, but one array, not the 2-dimension. But inside the list we are rearranging, so internally it to rearrange it shuffles the entire array, right? So for that it takes order of n square, not order of n. So yeah, the time complexity is order of n square, and the space complexity is order of n. Thank you. Thank you for watching my video. If you like my video, please subscribe, and thank you.